All right, today we're going to talk about something that's totally out there but also weirdly fascinating. Time travel. It's this amazing place where real cutting-edge science crashes right into our wildest imagination. So let's just dive right in, shall we?
So, right off the bat, let's start with a big question for you. Imagine there's a time machine right in front of you. It's humming, the door's open. You only get one choice, past or future. Which way are you headed? Go on, give it a thought.
Because that choice you just made, that gets to the very heart of what we're exploring. This idea that time isn't just some rigid, straight road we're all walking on. What if it's more flexible? What if it's, more like a playground?
And trust me, this is not a new idea. This desire to hop around in time is one of the oldest dreams humanity has ever had. It just keeps popping up, again and again, all through our history.
I mean, just think about it. From ancient legends all the way to the latest sci-fi blockbuster, we seem to be completely obsessed with the idea of slipping out of time's grasp. And that obsession, it totally shapes everything from the stories we tell to the actual science we pursue.
So, let's actually talk about that science, because this is where things get really wild. What sounds like pure fantasy? Well, physicists have been crunching the numbers on this for over 100 years. And it turns out, bending time might not be so impossible after all.
Yeah, this is way beyond just science fiction. We're talking about the heavy hitters here. Albert Einstein, Stephen Hawking. These brilliant minds basically rewrote the rulebook for the universe. And their work left us with these incredible clues that time is, well, it's just a lot weirder and more flexible than we experience it every day.
So, one of the first huge concepts you bump into is something called time dilation. And this isn't a what if. This is real, proven physics from Einstein himself. Basically, the faster you move through space, the slower time moves for you. And get this, it's happening right now. The GPS in your car or phone only works because the satellites orbiting way up there are moving so fast, their clocks literally tick a tiny bit slower than ours down here. That is a real working example of time travel to the future.
And then, of course, you've got wormholes. Now imagine you've got a big piece of paper. To get from one side to the other, you could crawl all the way across. Or you could just fold the paper in half and poke a pencil right through. That's the shortcut. And that's the idea behind a wormhole. A theoretical tunnel through the fabric of space-time that could connect two different spots in the universe. Or maybe, just maybe, two different spots in time.
So you have all these different fields of science that are all sort of pointing to the same strange conclusion. Einstein's relativity shows us time can stretch and shrink. The physics of black holes suggests gravity can get so intense it could literally tear a hole in space-time. Then there's the super weird world of quantum mechanics and the mind-blowing multiverse theory with its infinite possible timelines. It's like each one is another piece of this giant, incredible puzzle.
But here's the thing. All of this incredible potential, all these possibilities, they all lead to one simple but really profound question that has had scientists scratching their heads for decades.
Okay, just think it through. If all these theories are even partly right, and if humanity, maybe 1,000 years from now, finally cracks the code, then where is everybody, right? Why aren't we bumping into tourists from the year 3000 at the coffee shop? It's a fantastic question, kind of like the Fermi paradox about aliens, If they exist, where are they? It's the same idea, but for time travel. And there is no easy answer. This really leads down two main paths. On the one hand, maybe they are here. Maybe they're hiding in plain sight, just observing us with a strict rule, do not interfere. Or maybe the answer is a little more sobering. What if the laws of physics themselves have rules? Maybe you can go back, but you can't interact. You can look, but you absolutely can't touch.
So, we've talked a lot about some pretty huge cosmic theories. Let's bring it back down to Earth for a minute. Let's make this personal.
I want you to join me in a little thought experiment right now. Just a quick exercise to kind of get into that time traveler mindset.
Ready? Okay. First, just pick a moment, any moment in time. It could be something epic, like watching the pyramids being built, or something really personal, like your own 5th birthday party. You got one? Good. Now, just for a second, imagine you're there. You're invisible, just a silent observer. What do you see around you? What sounds can you hear? Can you smell anything? How does it feel to just be there?
That feeling, that little trip you just took inside your own head, that proves that time is so much more than just a clock on the wall. It's a landscape we can explore in our minds. It's a mystery, for sure, a giant puzzle. But maybe, just maybe, it's also a doorway.
Which brings us full circle, right back to where we started, you and that time machine. After exploring all the science, the paradoxes, the dreams, what's your choice now? Are you heading into the past to see what was, or are you shooting off into the future to glimpse what could be? The choice is yours.